Everyone's seen the base performance of the RTX 4080, but you bought this card because you want DLSS upscaling and frame generation. Well, I've got you covered. I'll be using my trusty Zotac Trinity to explore the extreme performance available to RTX 4080 users. So, how am I going to do it? Well, we'll start with everything on Ultra and turn on ray tracing where available. Then, we will upscale it all from nearest 1080p resolution. That means our 1440p resolutions will be using quality DLSS upscaling. Our 600p resolution will be using balanced. And our 2160p resolution will be using performance. This lines up with what some AAA developers are recommending. And then we will multiply the frame rate with frame generation. And finally, we'll use ray reconstruction where available. I have 9 games which support the full array of DLSS 3 features. One thing to keep in mind when looking at these charts is DLSS frame generation requires extra GPU resources. So, the less GPU resources you have, which include memory, the less performance you're gonna get. With that out of the way, I'll flash the specs of my test system on screen now. Pause the video if you want to take it all in. Now, let's get to those results. Let's start with what you really want to see, which is the average. First, let's set a baseline. Here is the 9-game average for the 4080 when you don't use any upscaling or frame generation. The lower 2 resolutions clear a nice smooth 60 FPS, while our higher resolutions for the most part manage to stay in a playable FPS range, though not a desirable one. Once we turn on DLSS so that everything is upscaling from roughly 1080p vertical resolution, we see the performance jump at all resolutions, and now the 2 lower resolutions are hitting high refresh rates and the higher resolutions are both in smooth range, easily clearing the 60 FPS mark without breaking a sweat. And finally, when we add frame generation in addition to the DLSS upscaling, we see very high refresh rates for the lower 2 resolutions. And that's it. There's nothing else to discuss here. Whoa, hold on there, Scott. Why is FrameGen only adding an additional 39, 37, 32, or 23% additional FPS? Why isn't it doubling the DLSS upscaled frame rate? Oh, that's because Nvidia FrameGen has very heavy overhead costs that gets heavier as your resolution goes up. With limited AI cores and DLSS upscaling already leveraging some of them, there just isn't enough bandwidth to actually double the frame rate you were getting before turning it on. As you can see, it wipes out all or nearly all of the frame rate gained by using upscaling and replaces them with generated frames, which will have more artifacting than the upscaled frames, although this is hardly noticeable if you have sufficient frame rate, like you're seeing at the 3440 by 1440 and 3840 by 1600p resolutions. As long as it doesn't affect text elements, as our visual processing centers are hyper-trained on recognizing those shapes, and any anomalies or flickering is very noticeable and distracting. Is there any way to improve this? Since it is all constrained by the AI processing on the GPU, the only way to improve things this generation would be to use a non-AI based technique. But Nvidia seems to be leaning all in on AI cores in future designs, so I imagine they will leave more enabled on the gaming GPUs that don't make the cut for the ultra-lucrative AI accelerators, effectively solving the solution with more brute force on future generations. I'm sure they'll also make the code more efficient along the way, but I wouldn't expect huge jumps in FPS for the 40 series cards when it comes to frame gen performance. If there isn't a solve for this generation, there has to be some games where it gets better performance, where it's worth turning on. Exactly. So if a game is using less of the GPU processing capacity, then there are more resources for the frame gen to tap into, especially in a situation where the game is CPU limited. You can get nearly double the frame rate, but this isn't always the case in a CPU bound scenario. Take for example a 500 FPS Counter-Strike game. The CPU is limiting its performance, but turning on FrameGen would not double your frame rate to 1000 FPS. It would actually lower your FPS as there's an upper limit to how many pixels a second FrameGen can make up. And the higher the resolution you're trying to generate frames for, the lower frame generation's maximum frame rate will be. Let's take a look at some of the games that see the best and worst frame rate scaling from frame generation. First, we'll start with one of the best performance, and then we'll look at one of the worst. So the first high scaling game for FrameGen is Cyberpunk 2077. Let's set a baseline of performance with the native raw frame rate, where we see the 4080 is a fair way off from hitting 60 at any resolution. Now, when we upscale everything from near 1080p, we see healthy jumps in performance, with the 2 lower resolutions getting smooth refresh rates comfortably beyond 60 FPS, but the two higher resolution monitors can't quite make it to 60 FPS, leaving them outside the Nvidia recommended 60 FPS needed before turning on frame generation. When we turn on frame generation anyways, we see an FPS improvement to the tune of 51, 51, 56, and 47% for each of the resolutions, bringing the lower two resolutions into high refresh rates and allowing the higher two resolutions to sail across the 60 FPS mark. Even as one of the best performing titles, we are only just seeing it achieve half of the frame doubling potential that frame generation promises is achievable at 3 out of the 4 resolutions. Now let's look at the other end of the spectrum with one of our worst scaling games, Call of Duty Modern Warfare 3, played on its extreme preset. Look at our baseline performance and we see the 3440 by 1440p resolution manages some very high refresh rates, just crossing the 120 FPS line. The 1600p Super Ultrawide are both getting high refresh rates, and even the 5K 2K resolution is easily passing the 60 FPS mark. Turning on upscaling, we see marginal benefits for all resolutions, with the 1600p joining the 1440p Ultrawide in very high refresh rates, and the 5K 2K now in high refresh rates with the Super Ultrawide. Turning on frame gen delivers only a marginal or worse frame rate increase. The 1440p and 1600p Ultrawides are seeing a 30 FPS jump, but that only comes to a 25 and 24% FPS increase for a technology that is supposed to be delivering a 100% increase in frame rate. The 1440p Super Ultrawide sees a mere 6% increase in frame rate, and the 5K 2K resolution actually sees negative frame rate scaling with frame gen on. There just aren't enough AI resources left to push that many frames at such a high resolution. So the second high scaling game for frame gen is Hellblade 2's Senua's Sacrifice. Let's set a baseline of performance with a native raw frame rate, where we see the 4080 can't manage to hit 60 FPS at any resolution. Now, when upscaling everything from near 1080p, we see a healthy jump in performance, with the two lower resolutions getting smooth refresh rates comfortably beyond 60 FPS, and the two higher resolution monitors coming in 1 FPS shy of 60 FPS. Turning on frame gen, we see an FPS improvement to the tune of 48, 47, 46, and 40% for each of the resolutions, bringing the lower two resolutions into high refresh rates and allowing the higher two resolutions to sail across the 60 FPS mark. Even as one of the best performing titles, we are not even seeing it achieve half of the frame doubling potential that frame generation promises is achievable. The next low performer is an interesting case where Forza Horizon 5's performance isn't much affected by resolution. We see minimal frame rate differences between resolutions even with the raw performance, and turning on DLSS is negligible for all resolutions except for the 5K 2K resolution, which is using the performance setting, but even there it's only an 11% increase. So the only real way to increase your FPS outside of turning down settings is to use frame gen, which delivers 38, 34, 30, and 24% increases in frame rate performance. Not a tremendously significant increase on this game because DLSS is giving so little and using up those AI cores. I tried the 3440 by 1440p resolution with no upscaling, only frame gen, and was able to improve upon the frame rate by 2 to 3 FPS. So, not upscaling is actually the optimal way to use frame gen in this title to maintain the best picture quality. Let's look at the rest of the field of games, then I'll draw some conclusions for you all. Starfield starts from a pretty high FPS, gets a decent showing from upscaling, especially at the highest resolution, but a rather lousy frames end result with 38, 37, 30, and 19% frame rate uplift. Jedi Survivor's last update seems to have broken upscaling on Nvidia cards, as both DLSS and FSR provide no performance difference from native on any of my Nvidia cards, despite it working in previous tests months ago, and FSR works fine on AMD cards, which was not the case at launch. Needless to say, this game hasn't shaken all of its bugs, but since I don't have a ton of frame gen games to choose from, and the frame gen still works, we can see it delivers one of our better results with 47, 49, 50, and 51% frame rate boost. Flintlock has a low native frame rate, similar to that of Cyberpunk, but when scaling is turned on, it gets a tremendous jump in performance. FrameGen further increases performance, but not by a terribly impressive amount, delivering a 35, 36, 33, and 22% frame rate increase. Remnant 2 sees the classic stair-step performance graph for the raw performance. Upscaling provides a healthy boost, bringing all resolutions into smooth or high refresh rates, and FrameGen provides a mixed bag with 42, 37, 36, and 23% frame rate increases. And finally, Immortals of Avium sees playable raw performance for most resolutions, with upscaling providing a significant increase, bringing everything into high or smooth refresh rates, and FrameGen provides a moderate increase of 39, 35, 34, and 26% additional frames. Looking big picture at all 9 of the games, you can see that for the 3440 1440p and the 3840 by 1600p resolutions, the games that get the most frame rate scaling out of FrameGen are games that are, after upscaling, land in the 70-ish FPS range. And as games approach and cross the 100 FPS mark, FrameGen returns are reduced, with the highest FPS games seeing the lowest returns. The FrameGen returns don't scale linearly with initial FPS, but it is highly correlated. When we look at the 5120 by 1440p Super Ultrawide and the 5120 by 2160p Ultrawide, we see the same correlation, just starting at a lower FPS, with the 50 FPS starting point, which is under the Nvidia recommended 60 FPS you need to achieve before turning on FrameGen, seeing the largest gain, with numbers tanking swiftly after as you approach 80 FPS, and we even see the highest FPS games actually lose FPS when turning on FrameGen. Looking at the final test results, we see that the RTX 4080 is able to play at 3440 by 1440 and 3840 by 600p, and 8 out of the 9 games at over 100 FPS. The only game that isn't crossing that line is Jedi Star Wars Survivor, and that's because right now, DLSS upscaling is not functional. And when that's patched back in, it will be over 100 FPS as well. Hell, Diablo 4 is supposed to be one of the games I tested, but the Vessel of Hatred expansion broke frame generation in this game during the period I was testing, and so it had to be excluded. But needless to say, the 4080 outside of some broken games sees extremely good frame rates at these 2 resolutions. For the 5120 by 1440 and the 5120 by 2160p resolutions, we see smooth frame rates above 60 FPS for all games except for the broken one. Although we do see in Cyberpunk 2077 and Hellblade 2, frame rates are below the recommended 60 FPS you need before turning on frame generation. They are very close, however, so you probably won't experience that much latency. But if you go much lower, latency issues will become a problem. While the percentage of extra performance frame generation is providing is rather disappointing, I mean it's not even half of the doubling of frame rate that this technology is touting, you're still getting a very nice frame rate, and 30 extra FPS is still a nice boost to smoothness of animation. So that's it. That's the kind of performance you can expect when turning on all the bells and whistles on an RTX 4080. Some very good average frame rates, even if the FrameGen scaling is a bit disappointing. Thanks for watching. Please subscribe to catch all my latest videos, and you can check out this video here if you want to check out how the 4070 Ti compared to the 700 XT when using all the bells and whistles on those cards. If I helped you make a GPU purchasing decision, please consider using my Amazon affiliate link below. It costs you nothing and helps me out. And if you want to help out the channel more directly, you can subscribe to my Patreon or become a member right here on YouTube. I'm Scott, and I'll see you next time, Ultrawide fans.